Hello viewers, in today's session we are going to discuss some important problems related to indefinite integration. And in this session we are going to discuss some conceptual problem related to indefinite integration using a substitution method. So let us first consider this problem. So here we can take this integral as I. Now here the integrand is sine x divided by 1 plus cosine x raised to 4. So here we can take the substitution, that is, let t is equal to 1 plus cos x, right? So when we take t is equal to 1 plus cosine x, then we differentiate t with respect to x. So we have dt over dx is equal to 0. The derivative of 1 is 0, and the derivative of cosine x is minus sine x. So now this is equal to minus sine x, right? So now dt over dx is equal to negative of sine x. So we can now write dt is equal to minus sine x and dx, right? So now here for this term, that is sine x dx, we can now take here minus dt. So we can take this negative sign to this side, so that sine x dx is equal to negative of dt. So now we can write this integral I in terms of t. So we have I is equal to minus dt for sine x dx, and here for 1 plus cos x we can write t. So we have a t raised to 4. So now we can take negative sign outside the integral notation, and we have t raised to minus 4, and here we have dt. Now we can use this result, that is integral of x raised to n dx is equal to x raised to n plus 1 over n plus 1. So here the value of n is minus 4, and here the variable is t, right? So we have minus, and then we can now write t raised to minus 4 plus 1 over minus 4 plus 1, and here we add the constant of integration, that is c. So now we have minus t raised to minus 3, and here we have minus 3 plus c, and this negative and this negative get cancelled, and we have 1 over 3, and we can take this t raised to minus 3 to the denominator. So we have now here plus c. Now let us again here substitute t is equal to 1 plus cosine x. So we have 1 over 3 and 1 plus cos x raised to 3 plus c. So the indefinite integration of this function sine x over 1 plus cosine x raised to 4 is given by 1 over 3 times 1 plus cosine x raised to 3 plus c, where c is the constant of integration. So now consider this problem. So here we have to integrate secant square logarithm of x plus 1 divided by x plus 1, right? So here we can take this integral as I. Now here we are going to make this substitution, that is t is equal to logarithm of x plus 1, because the derivative of log x plus 1 is 1 over x plus 1. Let us now differentiate t with respect to x. So we have dt over dx is equal to d by dx of a log of x plus 1. Now from the standard results we know that the derivative of log x to the base e, here the base is e, and we have 1 over x. So here the derivative of log x plus 1 is 1 over x plus 1, and then by chain rule, if we differentiate x plus 1, then the derivative of x is 1 and the derivative of 1 is 0. So this is 1 plus 0 is 1, so this is simply 1 over x plus 1. So we have dt over dx is equal to 1 over x plus 1. So now from here we can now write dt is equal to dx over x plus 1, right? So now for this term, that is dx, this is dx over x plus 1. So for dx over x plus 1, we can now write dt. So now this integral I, it takes the form in terms of t as integral, and we have secant square t, because here log x plus 1 is equal to t and dx over x plus 1 is dt. So now we have to find out the value of this indefinite integral, that is integral secant square t dt. Now again, from the standard results, we know that the integral of secant square theta is equal to tangent theta. So here we have the integral, that is simply tangent of t, and c is the constant of integration. Now we can replace this t by logarithm of x plus 1. So here we have log of x plus 1, and c is the constant of integration. So the value of this indefinite integral is given by tangent of logarithm of x plus 1 plus c. So now consider this problem. Here we have to find out the value of the indefinite integral of e raised to 2 sine x cosine x. Let us call this integral as I, right? So here we are going to make this substitution, that is t is equal to 2 sine x, right? So here we have t is equal to 2 sine x, because the derivative of sine x is cosine x, which is present over here, right? So now if we differentiate t with respect to x, we have dt over dx is equal to 2 times the derivative of sine x. So we have here 2 times cosine x, because the derivative of sine x with respect to x is cosine x. So now we have a dt over dx is equal to 2 cos x. So now we can write dt over 2 is equal to cosine x dx. So taking this 2 over here and taking dx over here. So now we have cos x dx is equal to dt over 2. So here for cos x dx, we can replace dt over 2. So now this integral I, it takes the form e raised to t, because t is 2 sine x, and cosine x dx is dt over 2. So now we can take half outside the integral. So we have here integral e raised to t dt, and we know that the integral e raised to x dx is equal to e raised to x. So here we have half, and here we have e raised to t, and c is the constant of integration. So now we can replace this t by 2 sine x. So here we have 2 sine x, and c is the constant of integration. So the indefinite integral of this function is given by half times e raised to 2 sine x plus c. So now let us consider this problem. Here we have to integrate cot x divided by logarithm of sine x, right? So now here what we will do, we'll take this substitution, that is t is equal to logarithm of sine x, right? Because the derivative of log sine x is equal to cot x. So if we differentiate t with respect to x, then we have d by dx of log of sine x, right? And here the derivative of log x is 1 over x. So here first we'll take x as sine x. So we have 1 over sine x, and then by chain rule we differentiate sine x with respect to x, and we have 1 over sine x. The derivative of sine x is cosine x. So this is cos x over sine x, that is equal to cot x, right? So now we have a dt over dx is equal to cot x. So we can now write dt is equal to cot x and dx, right? So now for this term, that is cot x dx, we can take dt. So we have now I is equal to dt divided by log sine x. Log sine x is equal to t, right? So now we have a simple standard integral, and we know that the integral dx over x is log of x, and here the base is e, right? So here we have the integral dt over t is a log of t to the base e, right, due to this result. So we can now write here c as the constant of integration. Now we can write log of t to the base e by replacing t by log of sine x. So here we have log of sine x, and obviously here the base is e, and c is the constant of integration. So the value of this indefinite integral is given by a logarithm of sine x plus c. Now consider this problem. Here we have to find out the value of this indefinite integral, that is e raised to square root of x sine e raised to square root of x divided by square root of x, right? So here what we will do, we'll assume t is equal to e raised to square root of x, right? So here we'll make this substitution, t is equal to e raised to square root of x. So let us differentiate t with respect to x. So we have dt over dx is equal to d by dx of e raised to square root of x, right? Now see, from this result, that is the derivative of e raised to x is equal to e raised to x. The derivative of e raised to square root of x with respect to square root of x is e raised to square root of x, and then by chain rule we differentiate square root of x, and we know that the derivative of square root of x is 1 over 2 times square root of x. So here we have e raised to square root of x times 1 over 2 times square root of x. So we have now dt over dx is equal to e raised to square root of x divided by 2 times square root of x. So now from this relation, we can take this 2 over here. So we have 2 dt, and we can now take dx to this side. So we have e raised to root x over root x, and here we have dx, right? So now we can write this integral I as integral sine e raised to root x, and we can take here e raised to root x dx over root x. So for this term, we can now write 2 dt, and for e raised to root x we can write t. So we have here sine uh, t, and for this entire term we can take 2 dt. So now we can take 2 outside the integral, so we have here sine t dt, and again from the standard results, the integral of sine x dx is equal to negative of cosine x. So here we have 2 times negative of cosine t, and c is the constant of integration. So now we have here minus 2, and we can now write uh, t as e raised to square root of x, and c is the constant of integration. So the value of this integral I is given by this expression. So now let us consider this indefinite integral. So here we have to find out the indefinite integral of 1 minus sine x divided by square root of x plus cosine x. So here we are going to make this substitution, that is t is equal to x plus cos x, because the derivative of x is 1, which is over here, and the derivative of cosine x is negative of sine x, which is over here. So now let us differentiate t with respect to x. So the derivative of x is 1, the derivative of cos x is minus sine x. So we can now take dx to this side, so we have dt is equal to 1 minus sine x and dx. So now for this term, we can now write here simply dt, because 1 minus sine x dx is equal to dt, and here we have square root of x plus cos x. X plus cos x is equal to t. So now we have dt over t raised to half. So we can take t raised to half in the numerator. So we have here negative of half and dt. Now using this result, we have now x raised to n plus 1 over n plus 1, provided n is not equal to minus 1. So here the value of n is minus half. So we have here a t raised to minus half plus 1 over minus half plus 1, and c is the constant of integration. So we have t raised to half, 1 minus half is half. Here also we have half, and now we can take this 2 to the numerator. So we have 2 times t raised to half plus c, that is 2 times square root of t plus c. So now we have the value of this integral I as 2 times the square root of t. T is x plus cos x, and c is the constant of integration. So now consider this problem. So here we have to find out the indefinite integral of e raised to 3x, and here we have e raised to 3x and dx, right? So here we are going to make this substitution, that is t is equal to e raised to 3x, right? Because when we differentiate e raised to 3x, then we have an expression involving e raised to 3x. right? So taking t is equal to e raised to 3x. So let us differentiate t with respect to x. So we have d by dx of e raised to 3x, and we know that the standard result for the derivative of e raised to say mx is given by m times e raised to mx. So here the value of m is equal to 3, right? So we have here 3 times e raised to 3x due to this result, right? So now we have a dt over dx is equal to 3 times e raised to 3x. So we can now take 3 in the denominator of dt, and we can take dx to this side. So we have e raised to 3x and dx. So now for this term, we can write dt over 3, and for e raised to 3x we can write t. So now this integral I, it takes the form e raised to, here we have e, and e raised to 3x can be written as t. So here we have t, and e raised to 3x dx can be replaced by dt over 3. So we can now take 1 over 3 outside the integral, and we have e raised to t and dt. Now the integral of e raised to t dt is e raised to t, and c is the constant of integration. So we have 1 over 3, and we can now replace t by e raised to 3x, and c is the constant of integration. So this is the required expression for this indefinite integral. So now let us consider this interesting problem, and here we have to find out the indefinite integral of 3 raised to 2 times logarithm of x to the base 3 times logarithm of x to the base x. So here we are not going to make use of substitution method, but here we'll simply make use of the properties of logarithm and exponential function, right? So let us first see this term, right? See, 3 raised to 2 times logarithm of x to the base 3 can be written as 3 raised to log x square, and here we have a 3, right? So we can take this 2 to the power of x using this result, that is log say m raised to n is equal to n times log m, and obviously here the base is e, right? Okay, so now here we can take this 2 to the power of x. So now here we'll make use of this important property of exponential function, that is a raised to logarithm of say p to the base a is equal to p, right? So here we have a, here also we have a. So here we have 3, here also we have 3. So if we compare this expression with this one, then the value of a is equal to 3, and the value of p is equal to x square. So this term is equal to simply x square due to this result, right? Okay, so the value of this expression is simplified to x square, and here we have the second term, that is logarithm of x to the base x, and here obviously x is greater than 0, right? And we know that log of a to the base a is equal to 1. So the value of this expression is simply equal to 1. So now our integral I, it takes the form, that is x square for this term we have x square, and for this term we have 1, because logarithm of a to the base a is equal to 1. So here we have 1 and dx. So we have simply x square dx. Now the integral of x square is simply x raised to 2 plus 1 over 2 plus 1, and c is the constant of integration. So we have x cube over 3 plus c, right? So the value of this indefinite integral is equal to x cube over 3 plus c. Now consider this problem. So here we are given f prime of x is equal to e raised to x minus 1 over 1 plus x square, and f of 0 is given as minus 1, and we have to find the function f of x, right? So here we are going to make use of the definition of indefinite integration to solve this problem. So here we are given the derivative of f of x is equal to e raised to x minus 1 over 1 plus x square, and the value of the function f of x at x is equal to 0 is given as minus 1, right? And here for f prime of x we write this notation d by dx of f of x, right? So here if we take this function as say a g of x, then d by dx of f of x is equal to g of x. So here we are going to make use of the definition of indefinite integral, right? So the derivative of f of x is equal to g of x, that is this function e raised to x minus 1 over 1 plus x square. So from this relation we can conclude that if the derivative of f of x is equal to g of x, then f of x is given by the integral of g of x plus c, where c is the constant of integration, right? So here we are given the derivative of f of x, that is f prime of x is equal to this function, and we have assumed this function as g of x, right? So when the derivative of f of x is equal to g of x, then f of x is given by the integral of g of x plus c, where c is the constant of integration. So now we can write f of x is equal to the integral of g of x, and g of x is given by this function. So we have e raised to x minus 1 over 1 plus x square dx plus c, and we can now write f of x is equal to integral e raised to x. So first we write this integral, then we have 1 over 1 plus x square dx and c, right? So here we have the standard results. So the integral of e raised to x is e raised to x, and the integral of 1 over 1 plus x square is simply tan inverse x, and c is the constant of integration. So our function f of x is now given by this expression, and here we have to find out the value of this c using this condition, that is when x is equal to 0, then f of 0 is equal to minus 1. So now taking x is equal to 0 in this expression, we have f of 0, and then we have e raised to 0 minus tan inverse 0 plus c. Now f of 0 is equal to minus 1, e raised to 0 is 1, and tan inverse 0 is simply 0, and here we have c. So we have minus 1 is equal to 1 plus c. So we have minus 1 is equal to c, that is c is equal to minus 2. So now let us substitute the value of c as minus 2 in this expression. So the value of f of x is given by e raised to x minus a tan inverse x minus 2. So this is the required expression for our function f of x. So now consider this problem. So here we are given f prime of x is equal to x plus a, where a is some constant, and f of 1 is given as 5, f of 2 is given as 13, and we have to find uh, f of x, right? So here again we'll make use of the definition of indefinite integration. So here f prime of x can be written as d by dx of f of x, which is equal to x plus a. So let us take this function as, say, g of x. So we are now given d by dx of f of x is equal to g of x, where g of x is given by this linear function, that is x plus a, right? So when the derivative of f of x is equal to g of x, then f of x is given by the integral g of x dx plus c, where c is the constant of integration. So now we can write f of x is equal to integral g of x is x plus a. So here we write x plus a dx and c. So we can now have f of x. Now the integral x dx, and here we have integral a dx and c. So we have now f of x is equal to integral of x is x square over 2, and here we can take a outside the integral sign. So we have a times integral dx, that is equal to ax. So here we have ax and c. So the function f of x is given by this expression, and now we have to find the value of a and c using these two conditions. So let us first make use of this condition f of 1 is equal to 5. So here we have x is equal to 1, and f of 1, that is f of x, is given as 5. So taking x is equal to, in this expression we have f of 1 is equal to 1 square over 2 plus a times 1 plus c, and f of 1 is equal to 5. Here we have half, here we have a plus c. So taking half to this side, we have 5 minus half is equal to a plus c. So now we have a plus c is equal to, that is 10 minus 1, that is 9 over 2. So this is our first equation, right? So now using this condition, that is f of 2 is equal to 13. So here we have x is equal to 2 and f of x is equal to 13, that is f of 2 is equal to 13. So taking x is equal to 2, in this expression we have f of 2 is equal to 2 square over 2 plus here we have 2a and here we have c. So f of 2 is 13. So here we have 4 over 2 is 2 plus 2a plus c. Taking 2 to this side, we have 2a plus c. So we have now 2a plus c is equal to 11. So this is our second equation. So now we have two equations. A plus c is equal to 9 over 2 and 2a plus c is equal to 11. So now we can easily solve these two equations. So now if we subtract these two equations, then here c and c get cancelled, and here we have a minus 2a is equal to minus a, and here we have 9 by 2 minus 11. So here a minus 2a is equal to minus a, and here we have 9 by 2 minus 11, that is equal to 9 minus 22 over 2. 2 times 11 is 22. So here we have minus 13 over 2. So we have minus a is equal to minus 13 over 2. Minus and minus get cancelled. So we have a is equal to 13 over 2. So now let us substitute this value of a in this equation. So we have a plus c is equal to 9 by 2. So we have 13 over 2 plus c is equal to 9 by 2. So we have 9 by 2, taking 13 by 2 to this side, we have minus 13 over 2. So here we have 2, then 9 minus 13, that is minus 4 over 2, that is minus 2. So the value of c is equal to minus 2. So now let us substitute these values in this expression. So f of x is now given by x square over 2, and for a we have 13 over 2, and here we have x, and c is equal to minus 2. So this is our required function f of x, and from this expression we can see that the function f of x is a quadratic function.